bear with us while we get the live stream set up. We'll start in a few seconds. Welcome, everyone. We have Stan here, who is going to give you a workshop on zkSync for Builders 2.0. And if you have any questions in the meantime, feel free to pop them in the chat and we can take them towards the end. Stan, I'll let you take the stage. Thanks.
Hi, everyone. So today we're going to have a talk about zkSync 2.0. zkSync 2.0 is the first EVM-compatible zk rollup, and we're going to discuss how it feels from the UX, from the user perspective and from the developer perspective. zkSync 2.0 has been live on testnet since February, and a quick disclaimer here is that this presentation not only shows the features which are already available on testnet, but also the ones which will be available in the future. So what is zkSync 2.0? As already said, it's an L2 powered by zkEVM. The main features compared to other zk rollups is that it is programmable in Solidity and Viper. It has full support for F3 API. That means that most when works, presumably integrations with various indexers like the graph, they will be done very smoothly. And also your frontend will most often work out of the box. And security and censorship resistance are inherited from L1. zk rollups and rollups in general, they solve the problem of Ethereum scalability. So for instance, currently users most often have to choose. They either pay high fees and use highly decentralized blockchain like Ethereum, or they should use something like a sidechain like Solana or Phantom or whatever. And while rollups do solve this issue partially, they only offer linear throughput boost. That means that on zkSync, the transactions can get 10x, 20x, 100x cheaper than on Ethereum, but they will always be bounded by the limitations of Ethereum. Even with the new EAPs like Dank sharding and block transactions, while getting cheaper, there's still some limitations imposed by the underlying L1 chain. That's why we will also introduce zk Porter. zk Porter is basically a second shard of zkSync, which will be synchronously interoperable with zk rollup. It will have full security by L1. It will be fully secured by zero-knowledge proofs. However, and it will also have all or none censorship resistance. So while rollups inherit fully censorship resistance, like from the underlying chain, zk Porter will allow either everyone to exit or nobody to exit. And in return for this small drawback, it offers limitless throughput. So the fees are comparable to other sidechains. And as I said, these two parts, zk rollup and zk Porter, they're synchronously interoperable. That means that retail users and whales, they can all coexist together in a single big ecosystem. All of our code is MIT license. We use only permissive licensing for our code. We want not to govern the community, but the community to govern us. From the point of user experience, zkSync will provide the same with all the bridging which you would expect from a developed blockchain, like native deployments from L1. We have a lot of partnerships with exchanges. We have partnerships with on-ramps. Unlike optimistic rollups, we will support fast withdrawals to L1, which will take hours, not days or weeks. And the conventional bridges to other chains will be supported as well. To interact with zkSync, you could use any Ethereum wallet. So if you have your MetaMask wallet, no need to install any new one. You can just continue using all your accounts. We will natively support most of the contract interactions. So I will mention it in the developer experience later on, but this means that the code base for, unless you need to deploy contracts or allow users some zkSync specific features like paying fees in your C20 tokens, all the code base could be reused. As it said here, I will show you later an example of the P712 message. And also users have instant confirmation, so no need to wait seconds or minutes for the transaction to be accepted for the block. The acceptance is almost instant. And unlike Ethereum, users don't need to worry about paying fees in ETH. So if user has only USDC, they can directly pay fees with it. Here is an example of how it looks like, how a message, an EP712 message for a transaction where the fees are to be paid with USDC looks like. We will also support account abstraction. Currently, the most popular wallet on Ethereum is MetaMask, but MetaMask may not offer the best experience, especially for the new users. I wouldn't recommend MetaMask for my grandma, mainly because, like managing all these seed phrases and private keys, etc., it may be intimidating and very confusing for new users. Argent tries to resolve this with social recovery, where instead of private key controlling your account, you still have private key, but if you lose it or it gets stolen, you can gather your friends and they can recover your account. And these wallets, when they were implemented on Ethereum, they did not work out really well, mainly because of the huge fees for smart contracts, and also because Ethereum only treats EOAs as first-class citizens. With zkSync, smart contract wallets will be first-class citizens as well. It will also enable protocols paying for gas. For instance, imagine you could swap on Uniswap without needing to pay any fees. And also applications like Tornado Cash, they could use account abstraction to allow the users to withdraw funds without using any relayers. Who knows what Tornado Cash is? They know that to maintain privacy, Tornado Cash uses relayers for their users to be able to withdraw the funds. With zkSync, the Tornado Cash contract itself could withdraw them. From the developer perspective, our main job was to make migrating existing code bases as easy as possible. That is, to make the changes as minimal as possible. Most of the dApps which you could use will work out of the box. And even though if you only interact with contracts, you could still use ethers.js most often. We still recommend you to migrate to our SDK because it allows more flexibility. And most often the migration will look like that. You just change the import and that's it. The rest of the code will be the same. There's still some differences. For instance, here we did not mention how to instantiate the provider, but we are working on reducing differences and minimizing them. Here's an example on how to pay fees in your C20 token. So here's an example of how a user could do a contract interaction while paying fees with USDC. Just provide an override and that's it. Smart contracts come with some permanent changes. For instance, because the KVM bytecode is different from Ethereum one, create to opcode address derivation will differ. Create has slightly different reason why it might differ. We're still discussing it internally, but for now, that's how it is. Currently, we do not support native Ethereum, so payable is deprecated. You could still use it, but message value is always 0 anyway. Self-destruct will be removed, but it's the same way as Ethereum goes. And Ethereum learned that supporting self-destruct is a lot of pain. And since we're building a new chain, we can afford ourselves to not to learn lessons from the past. And also the gas pricing will be different. We don't currently support Solidity before 0.3. Also, on the current testnet, we only support Solidity 0.8, but soon we will also support older versions of Solidity starting from 0.4. Some OpenZeppelin libraries may not work right now because some opcodes are not available, and some tooling needs adaptation. That's the biggest part where you have to do some changes. because of the different deployment procedure that it requires EP712 messages, like here. The existing tooling, like typical Hardhat plugin may not suit zkSync. You would need to install zkSync specific Hardhat plugin. Also, some crypto precompiles won't work, though SHA-256 and DC recover will work, as well as KKAC. So the most popular functions are available. What will work? Everything else, and also Viper. From the point of front-end, most of the code bases can be maintained the same. So for instance, legacy TX format will be supported. Also on our testnet, all transaction formats from Ethereum are supported, but in the future, we may change that. Web3 API fully compatible, that means that, again, ethers.js works out of box. All the tooling, most SDKs in all other languages will work out of box as well. Also, we provide our custom SDKs. Currently, they're available only for TypeScript, but later on, we may develop also for other languages as well, like Rust, Go, Python, etc. If you want to get started, here's the link to the documentation. Also, I would really like to emphasize regarding account abstraction, that in order to allow mass adoption for account abstraction, your dApps should not assume that you always interact with an EOA. You should not, if your dApp or contract requires some signature verification, do not use EC recover. You could read more about it here. I will paste the link. Yeah. Okay, I'll answer all the questions in the end of the presentation. Okay, so our main security model is that everything that you write on Ethereum will work on zkSync, and our job is to make sure that the old audits are not affected. Also, since we use validity proofs, the validity is enforced by Ethereum. So after any new block, we publish proof on Ethereum that indeed all the transactions, all fee charging, etc., in the block was correct. As already mentioned, we also plan support for mass exits. Currently, let's say that some L2 becomes malicious, doesn't matter what rollup. What happens next? Then most of the users will have to move their funds from L2 to L1 and then move them to some other L2. This is unsustainable. If there are a lot of users, it will be too expensive, and there will be a lot of users who will not be able to migrate to another rollups. That's why in our long-term roadmap, we will support mass exits to allow users to migrate to another fork of zkSync, or maybe to another rollup if we ever go malicious. As we already said, it's not us that controls the community, it's the community that should control us. And that this way will provide an analog to L1 blockchain forkability. That if an L1 blockchain becomes malicious, you can always fork away from it. That's all I mentioned. We also have partnership with leading security audit firm. So we are both having thorough audit for ourselves, and we're also willing to support our partners with getting audit for themselves. Here's our ecosystem. As you can see here, are various DeFi projects like Zigzag, Curve, NFT, Metaverse, DAO, etc. Ecosystem grants, as already mentioned, an example of Hardhat tooling, which has to be changed, adapted to be supported by zkSync. We also support various ecosystem grants for developers who are willing to adapt existing tooling to zkSync, like Hardhat, Truffle, Remix, Foundry, Waffle, etc. All this tooling should be adapted to zkSync. The changes are not big, but they still need to be made, and we would really appreciate any help from the community. If you have any other ideas, what tooling do you miss from zkSync, please let us know and we'll surely consider it. Thanks, everyone. I think here's the time for questions. I'll take a look in the chat. Do you support ModX precompile? No, we do not. Currently, the only precompiles that we support are SHA-256 and EC Recover, and also KEK. Hi, Stan, there WebSocket RPC available? Yes. Any Oracle available? We are partnering with various Oracle companies, but on the testnet, there are no Oracles as of now. I think that there will likely not be much Oracles on the testnet. I may be wrong here, but I think most of the projects, they want to launch on mainnet. No more questions in Zoom. Maybe there are some in the YouTube.
Stan, no more questions. And
Okay.
if there's any questions in the meantime, we can follow up over Discord.
Sure.
Cool. Thanks again. Thanks, everyone. See you at the next workshop.
Thanks, everyone.
Thank you.